Hello, in this video in U.I.L computer science we'll be talking about if statements. And if statements are really easy. So let me just title this video if statements. So this is how they work. If condition is true, do this, right? As in like the code. And then else do this. Condition is not true. Now you don't have to use the brackets if it is a single line. If it is a single line of code, then you could just put the code right here and it'll work the same. You don't need a condition for the else statement because it already knows that the if statement is false. That's where you just hit else and then type in the code. That's pretty much it. For the if, you do need a condition. And to do those conditions, you can use these symbols. This is less than or equal to, greater than or equal to, and not equal to. So these are your comparison operators. If you want to use like the Boolean symbols, then you could use this for or. Oops, I did that wrong. This for and, right? And the two ampersands, right? And this for exclusive or. So again, less than or equal to, greater than or equal to, not equal to, or, and exclusive or. Okay. If you want to use multiple ifs, then you can use what's called an else if statement. It works like an if, but it's like, okay, the if statement was wrong, now we can go to the else if statement. If this else if statement is wrong, then we can go to the next else if statement. Or if the next one is an else statement, then we know that both if statements were false. So an else if is an if, but it's only gonna be run if this if statement is false. So just treat it as another if statement. I mean, technically, if you want, you could just leave it as an if statement, but it's good to know. Another important thing that we can do, another important concept, at least in if statements, is short circuiting. This is very important because it makes if statements a whole lot of sense. So let's figure out int j equals to 34, right? And we say int p equal to 0 if p is greater than 2 and plus j equals to 19, then we'll do some code. Okay? And then we're gonna print j. Cool. So, what do you think the answer is? Well, some people may think, oh, it's gonna be difficult because we didn't even know what the code is in if statement, but that's not even important. Let's run to the code. So if P is greater than 2, that's our first condition, right? Is 0 greater than 2? No, that is false. If you know your Boolean like logic, anything that is false and like it gets added with something else, it's automatically going to be false because of this ampersand, right? I mean the and. True and false is false. False and false is false. False and true is false. But only true and true is true. So they both have to be true to be true. But because this first one is false, Java doesn't even care about this part. The whole thing's automatically false, so you don't even have to do the code. So system.out.print j, well, j is 34. So the answer is 34. Again, this one was false, and because we were adding a false, the whole thing is automatically false. So Java doesn't even have to check this. Therefore, j never gets incremented by 1. Okay? We can fix that by using bitwise Boolean, which I already mentioned in a previous video. And bitwise Boolean only has like, so you know how we have or and, right? Well, with bitwise Boolean, there's only one of the symbols gets used. So let's say we bitwise Boolean, right? So let's only use 1 ampersand. It only using 1 ampersand, the whole thing still works, okay? So let's do it again. P is greater than, if P is greater than 2, is 0 greater than 2? False, right? This time, you don't short circuit. You keep on going. Plus plus j equals to 19. We all know that when we have plus plus something, with the 2 plus lines before a variable, you automatically increment it by 1. So we're going to increment j by 1, and it's going to be 35. Does 35 equal to 19? No, it doesn't. So the if statement doesn't even get used, right? So now we're going to print out j. Well, we incremented j by 1, so now the answer is not 34. The answer is 35. So, again, to short circuit, if you want to short circuit, then you would use the regular Boolean symbols, the double ampersand or the double ors or whatever, right? Well, not double ors, double ands. So when we had the double ampersands, 0 was less than 2, so the whole thing didn't even matter, not even this part. But when we use bitwise Boolean, Java checked every single condition. And in this case, the condition said that j has to be incremented by 1. So if we did that, the code still was false. Either way it would have been false because this guy was false. But with single bitwise Boolean, then you would have to check every single condition. So the whole thing was false. J got incremented by 1. We print out j, which is now 35. So that is short circuiting. And now we'll move into the last bit of this video, which is let me get a sheet of paper. Put this in frame. It's called a ternary operator. Ternary operator. So what happens is let's have int w equal to 42, and we'll say string s equals to w equal to 42 question mark universal colon answer. So basically we're gonna print w, oops, nothing, forget that period, that's a mistake. I'm just gonna put an underscore, okay. Yeah, I meant for it to be a space, but now it's gonna be an underscore. Okay. So basically, this is a ternary operator. Okay. This is the same thing as saying if W equals to 42, S equals to universal. Oops. Okay. Else S equals answer. Right. So does W equal 42? Yes, it does. So we're gonna print. Well, S is now universal. So when we print this, it's gonna print. W, which is 42. And I made a mistake. I meant to put a space, but because I used an underscore, I'm gonna print an underscore. And then S we said was universal because W does equal 42. So now it's gonna print universal. So if this part's true, this is gonna be the output, and if it's false, then this is gonna be the output. So this is just basically an if-else statement, but like condensed to one line of code. And yeah, it's a ternary operator, not that hard. Basically an if-else statement. And yep, that is it for this video. Bye.